Let's begin this lesson with asking a question. What is a probability that no two students in our class of 25 students share a birthday? And let's assume for the sake of this question that no one was born on February 29. Okay, so I want you to imagine the problem this way. So instead of thinking of the big question, which is how do you get 25 students not to be born on the same day, I want you to think about, well, what if I just had one person come into a room? So if one person came into a room, what's the probability they share a birthday with no one in the room? Well, because they're the first person, there's a 100% chance that they have their own unique birthday. And next up, we ask, well, okay, another person comes into the room. So they walk in, and what's the probability that they do not share a birthday with the first person in that room? Well, if you think about it this way, there are 365 days in a year. And this person can be born on any other day except for the birthday of the first person. So this is the first person right here. So they have 364 days to have been born that were not the same as the first person. So there's a 364 out of 365 chance that they are not born on the same day. Well, the third person walks into the room, and now they also have 365 days in a year in which they could have been born, but they can't be born on one of the 2 days that the first two people are in. So they have 363 days to choose from. And the fourth person would have 362 days out of 365. And this problem just goes on until we hit the 25th person. Okay, so we can think about it. What would we do with these numbers here? So if you think about it this way, the first person's born on their own unique day, and the second person's born on their own unique day, and the third person is born on their own unique day. So each and is a multiply in this situation. So we need some number out of this. Well, that would take a lot of work on a calculator. So instead I use a spreadsheet. And you can see on the spreadsheet that I have student number 1, 2, all the way up to student number 25. So student number 25 has 341 out of the 365 days that they could be born. Okay. And each probability is noted in each of these sections here. Okay. So the probability that the 8th person is born on their own unique day is a 98% chance, or the 25th person, there's a 93% chance that they are born on their own unique day. However, we're looking at the probability that every single person has their own unique day. So what we're doing is we're taking this and we're multiplying it by this, and we're multiplying, and we just keep going down this whole probability column there. And we end up with the probability that no one has the same birthday is a 43% chance. So when you walk into an average classroom, it's actually quite likely that two people share a birthday, because there's a 43% chance that everybody has their own unique birthday, which would mean that there's a 57% chance that two people in that room might share a birthday. So that was 43%. Let me just double check there. Yeah, 43% chance with 25 people. It's probably a lot less likely than you were thinking. You were probably thinking it was a far greater likelihood that nobody shares a birthday, because there's just so many days to choose from. Okay, let's look at another question. There are 6 males and 2 females up for election for the student council. 4 people will be elected. What is the probability that no females are chosen if the student council is randomly chosen? So we have 6 males, we have 2 females. In total, we have 8 people up for election, and we are choosing 4 of them. Now, because we're choosing 4 of them, and order doesn't seem to matter here, there's not like a ranking of a president or vice president or anything like that. We know that the total number of ways to get a student council is 8 choose 4. Now the probability that there are no females, well, what would happen here is that only males make it in and none of these females make it in. So we'd have to choose 4 males, and it would be 6 choose 4 on top. So 6 choose 4 is 15 and 8 choose 4 is 70, which gives us 3 over 14. So it's quite unlikely that you would have no females in this group. What is the probability that there is 1 or less females? Okay, so probability that there is 1 or less would be equal to the probability that there are no females or that there is 1 female. Okay, so the probability that there is no females, we already figured out, was 3 out of 14, plus the probability that there is 1 female. So the probability that there is 1 female would imply, well, okay, let's start with the 2 females. So we have 2 females and they're choosing one of those positions. And, so we multiply. We have to look at the big picture because it could be male ABC or male ABD or male ABE. And each of those would be different student councils. So we have to look at the big picture of, well, how would the males play into this? So if there is 1 female, there is 3 males chosen from the 6. And on the bottom here, we have 8 choose 4. So this equals 3 over 14, and 2 choose 1 times 6 choose 3 is equal to 40 over 70. So that gives us 3 over 14 plus 4 over 7, which is equal to 11 over 14. So there is an 11 over 14 chance that 1 or less females is present in the student council. So that would also imply that it's quite likely that you have 3 or more males. Okay, next one. 3 children run to get in a line. What is the probability that they arrive in the order of height from tallest to shortest? So probability of, we'll call that being in order, and we're assuming tallest to shortest. Well, there's only one way to get them in the right order, so that would be having them from the tallest to the shortest. So you'd have the tall person, the medium, and then the short. Now, how many different orders could the kid show up in? Well, that would be 3 factorial, because each child showed up in any order. So 1 over 3 factorial is 1 over 6. And notice that this would be the same if you chose, you do 1 over, and you could do 3, and we're permutations. So 3p3. That would be the same. So that would be 1 over 6 as well. Okay, so what is the probability that they do not arrive in order of height? Well, there's complicated ways to do this, but there's simpler ways as well to do this kind of question. So if they do not arrive in order, what we could say is we're looking at 1 minus the probability that they do arrive in order. And that would be the probability that they do not arrive in order. Okay? So that would be 1 minus 1 over 6, which is equal to 5 over 6, which is the probability that they do not arrive in order. So in the work today, you will choose between using simply n of a over n of s, so the number of ways of A happening over the number of ways of S happening, And with some of those, you're going to have to think about, well, do you want to use NPR permutations or NCR combinations? And the difference is NPR order does matter, and in NCR order does not matter.